Now, not all transformations take rectangles onto rectangles, and not all transformations increase the length of vectors by the same factor, as I think this one does. Yeah. Okay. Anyhow, what if the transformation was given by this matrix? Now you see, I wrote the transformation out, you know, that V1 goes to V1 plus 2V2, and V1, V2 goes to this vector. Now I'm just going to say, well, we can just say all that with the matrix. We don't really need this rule. So here's the matrix. We apply the matrix to the vector 1, 0. As you can easily verify, we get 1, negative 3. Apply it to 1, 1, we get 3, 1. Apply it to 0, 1, we get 2, 4. Apply it to 0, 0, we will get 0, 0. Any matrix multiplied by 0, 0 gives you 0, 0, as you well know. Now I've done this more to scale, and with enough accuracy that we can see that the transformation doesn't preserve angles. Interesting concept, interesting fact. Okay, and you can plot the vectors just as well as I can and see that the picture ends up looking like this. The determinant of this matrix is still positive. In this case it's 4 and 6 is 10, so that this figure will have 10 times the area of this figure, and that's kind of plausible from the two figures. If I cut this out of the board, cut this out of the board, it might well take 10 of these to equal the weight of one of these. But that's what this transformation would do. Okay, so the next question is there some vector that maps onto a multiple of itself? Okay, well, this vector gets rotated this way. Okay, the yellow vector gets rotated this way. The orange vector gets rotated this way, but not as much as the yellow vector does. And the blue vector appears to be rotated this way. Now, it's very plausible that somewhere in between some of these rotations, maybe someplace out here, there might be a vector that doesn't get rotated at all. It just keeps the same direction, but it's almost certainly going to change length due to the way this transformation works. And the question then is, does there exist a vector here such that its transform vector is a multiple of it? Because remember that a vector is a multiple of the other if it runs along the same line. It might have the same direction, it might have 180 degrees, the direction might be 180 degrees away from that vector, so it might have exactly the opposite direction. But any multiple of one of these vectors is either going to go along this way or this way. Okay, so if it's the orange vector, it'll either be a vector in this direction, same direction as the orange vector, or this direction, the direction opposite that of the orange vector. And that's what we're going to look at next.